Do you ever wonder what happens if someone falls into a black hole? It's a thought both terrifying and fascinating. But before we imagine plunging into the abyss, let's uncover the secrets of black holes, how they form, the different types that exist, and how humanity has pieced together these cosmic puzzles. A black hole isn't just a void, it's the ultimate trap. Imagine gravity so powerful that nothing, not even light, can escape. But how does such a thing come to be? Most black holes are born from the violent deaths of massive stars. When a star, many times larger than our Sun, exhausts its nuclear fuel, it collapses in on itself, triggering a supernova explosion. What remains is a singularity, a point of infinite density surrounded by an invisible boundary called the event horizon. Beyond this point, escape is impossible. And not all black holes are the same. Each type tells a different story of cosmic evolution. Stellar black holes. These are the most common, formed from the collapse of massive stars. Despite being relatively small, just a few times the mass of the Sun, they are incredibly dense. Picture an entire star squeezed into a sphere the size of a city. Supermassive black holes. If stellar black holes are city-sized, these are galactic giants. Found at the centers of most galaxies, including our Milky Way, they are millions to billions of times the Sun's mass. But how did they grow so large? Did they form from smaller black holes merging or from collapsing gas clouds? Their origins remain a cosmic mystery. Intermediate black holes. These are the missing link. Larger than stellar black holes, but smaller than supermassive ones, they might form when several stellar black holes merge. Scientists are still searching for definitive proof of their existence. Could they be the seeds from which supermassive black holes grow? Primordial black holes. The strangest of all, these tiny black holes might have formed moments after the Big Bang. They could be as small as an atom, but with the mass of a mountain. What's more, some theories suggest they might account for dark matter, the unseen substance making up most of the universe. And here's a twist. Black holes might not always remain black. Stephen Hawking theorized that they emit radiation, now known as Hawking radiation, causing them to slowly lose mass. Could black holes eventually evaporate completely? If so, what happens to everything they've consumed? These questions drive humanity's exploration. How did we even discover black holes? For centuries, they were just theoretical. Einstein's general theory of relativity predicted their existence in 1915, but even Einstein himself doubted they could form. It wasn't until the 1960s and 70s that evidence began to pile up. One of the first black holes identified was Cygnus X1, discovered through X-ray emissions from a companion star being devoured by the black hole. Decades later, in 2019, we finally saw the unseeable. The Event Horizon Telescope captured the first ever image of a black hole. That glowing orange ring, framing a dark void, wasn't just a picture. It was proof of Einstein's theories, confirmed a century later. But how do we study something that doesn't emit light? Black holes reveal their presence through their gravitational influence. They bend light from nearby stars, distort space-time, and generate immense energy in their accretion disks, the swirling matter they pull in. So back to our burning question. What happens if you fall into one? If you were to approach a stellar black hole, you'd face spaghettification. The gravitational pull on your feet would be far stronger than the pull on your head, stretching you like a noodle until, well, let's not go there. But falling into a supermassive black hole might be less dramatic at first. The tidal forces near the event horizon are weaker, so you could cross it intact. But here's the catch. Once inside, all paths lead to the singularity, a point where space, time, and physics as we know them cease to exist. And yet, black holes might not be the dead ends we imagine. Could they be wormholes to other parts of the universe? Or gateways to parallel realities? Some scientists even speculate that our entire universe could exist inside a black hole. Here's another mystery. What happens to information consumed by a black hole? Quantum mechanics suggests information can't be destroyed, but general relativity says it's lost forever. This paradox has baffled physicists for decades. Hawking radiation might hold the answer. Could it carry traces of this information back into the universe? Black holes are more than cosmic monsters. They are keys to the universe's deepest mysteries. How many more black holes are out there, silently lurking? Will they help us unlock the secrets of dark matter, the Big Bang, or even the nature of time itself. The more we learn, the more questions we uncover. Black holes are the ultimate cosmic enigma. What secrets will they reveal next? Black holes may still hold secrets we can't even imagine. If you want to journey further into the unknown with us, let the algorithm know by giving us a thumbs up and hitting that subscribe button. Who knows what mysteries will unravel next?